Welcome to Analytics Nexus. Thanks for joining us for Jim Stern's presentation, 6 Rules to Keep AI from Taking Your Job. Jim Stern focuses his 35 years in sales and marketing on creating and strengthening customer relationships through digital communications. He sold business computers to companies that had never owned one in the 1980s, consulted and keynoted about online marketing in the 1990s, and founded a conference and a professional association around digital analytics in the 2000s. Following his humorous Devil's Data Dictionary, Stern published his 12th book, Artificial Intelligence for Marketing: Practical Applications. Stern founded the Marketing Analytics Summit, formerly the eMetrics Summit, in 2002, which was the birthplace of the Digital Analytics Association. He served on the DAA Board of Directors for 15 years and is now Director Emeritus.
Thank you, everybody, for joining me. I actually want to thank you for joining me because this is one of those cases where it's not a room full of people, it's just me and you. So I am really excited to be able to participate in Claravine's Analytics Nexus for 2020 and talk about the 6 rules to keep AI from taking your job. Now, my name is Jim Stern. I started the Marketing Analytics Summit back in 2002, and the audience created the Digital Analytics Association in 2004. That and about a dozen books on online marketing and analytics have kept me pretty busy with my most recent Artificial Intelligence in Marketing. But mostly, people want to know how they're going to keep artificial intelligence from taking their job. And before we start, the most important thing for you to understand, I love this little gaping void graphic. Understand that data is what we have, information is what we think we have, knowledge is what we eventually gain over time, insight is what we want, it's what we're looking for, it's what we wish we had, wisdom is what we actually need, but none of that actually matters without the data, the information, the knowledge, the insight, and the wisdom having an impact on the work we're trying to do. So that's just broad framing. Everything that I say follows from this. It's all about impact. Okay, 6 rules to keep AI from taking your job. Before I actually list 6 rules, it really probably matters how to identify or define artificial intelligence. It covers a broad area. It's a big umbrella term that is pretty much everything that's exciting about computers that we don't quite understand. Natural language understanding, natural language processing, taking my voice, turning it into text, analyzing text for meaning, figuring out how to respond so you can have a conversation with the computer, and then letting the computer see things, so computer vision, robots and self-driving cars, because everybody loves robots. But the one that we care about the most is machine learning. Machine learning is the thing that is going to start doing tasks for us. And the fear is that if it does enough tasks, we're no longer necessary. But artificial intelligence in general is just this broad term. It means really cool stuff that computers can do nowadays. So you want 6 rules to keep AI from taking your job. They are pretty straightforward. What do you want to be when you grow up? What technology are you going to use to get there? Do you really understand your raw material? Are you using these tools to make yourself a better marketer? Are you ready for a branding problem that we haven't faced before? And then, are you ready for something really weird? Going, you know what business to consumer is, and you know what business to business is. We're going to be entering a machine to machine marketing era. And I want to talk about all of these things, starting with, what do you want to be when you grow up? The last real job I had, working for somebody else, was 35 years ago. And I had a horrible boss. And I worked for that boss for a year. And I went to that boss's boss and said, hey, I'm not getting along. This isn't working out for me. And I don't think he likes me either. So help me find something else to do within the company, because I love the company. I'm fascinated by the product, great space to work in. And the guy said, well, what do you like to do? And I was flummoxed because it's work. It's not what you like to do. It's what people pay you to do because they wouldn't do it on their own. It's work. And he said, no, no, no. What was the last time you thought, wow, this was really cool while you were on the clock? I said, well, I went to that user group meeting and I gave that presentation in front of a couple of hundred people, and they paid close attention and they asked questions and they thought I was really smart, and that was really cool. He said, yeah, no, you can't do that at this company. You have to be the founder or the person who wrote the algorithm. You can't just be a company spokesperson. I said, really? He said, yeah, sorry. I said, oh, well, then I quit. And I did. Not as flippantly as that. It was a painful decision, but I realized I was not going to be happy there. And now 35 years later, I have spent several decades giving presentations in front of large groups of people about technology that I think is really cool. And I created a space for myself. So what do you find fulfilling? What do you think is interesting? Do you want to be the business decision maker? Do you want to be the analyst who lives between the business decision maker and the data? Are you fascinated by statistics and you want to be a predictive analyst? Or maybe you like building things. Maybe you are a maker and you want to build data platforms and pipelines and data cleansing tools for other people to use. Or maybe you're a data scientist and you really want to invent new algorithms and figure out which ones will make the best models to solve a problem. Or maybe you want to go into machine learning and really dig into the math theory and invent new ways of programming. These are different aptitudes. Now, you don't have to pick one. You can be several of these. And if you're all of these things, you are a unicorn and you will be paid far too much because I don't believe you. But you get to choose what you want to do when you grow up. And that's going to help you identify where to go deep. And that's what matters. Next is, what technology are you going to use? So you know that if all you have is a hammer, and I have to apologize for the badger there because I feel really sorry for the badger. But if all you have is a hammer, everything looks like a nail, and you really need to have multiple tools. So you have to choose from multiple tools to figure out what's going to make you a smarter, better marketer, a smarter, better analyst. Now, let's describe tools. So we're talking artificial intelligence. That means machine learning. Let's describe how it's different. Probably you're listening to me, undoubtedly you have done some kind of coding, whether it's C++ or Java or even HTML, or in my case, COBOL and Fortran. You have told the computer exactly what to do. Step A, step B, step C. If you get confused, kick out an error message, and if it all goes to hell in a handbasket, it's the blue screen of death. Ugh. But it is specific logic telling the computer what to do. Or you can create a mathematical model. You can put in the variables that you're interested in, the values for those variables, the relationships between them, the flow of logic, and then iterate and play what-if games. And yes, I just described an Excel spreadsheet. It's programming. It is a type of programming that's different from straight C++. Now, when you get to statistical analysis, predictive analytics, it is looking at the data and trying to build a model that accurately enough describes that data that it can predict what's going to happen next. It is playing with likelihoods and probabilities rather than accounting. And it is a complex science. It's statistics. It is the models that are built are fragile and require iteration and testing and can be very valuable and very useful. Then we get to this thing we call machine learning. Machine learning looks at the data and analyzes it for structure, analyzes it for relationships. It builds a model based on the data. And then when the data changes, it updates the model. It changes its mind. This is a different kind of programming. Now, you can call it artificial intelligence. The word intelligence applies because if you understand the expression that intelligence is the ability to adapt to change. Intelligence is the ability to adapt to change. So if something is not quite as expected, a computer falls over. But if it can adapt to change in the data, then we call it intelligent. Now, many of you understand all of this already, but for the several of you who don't, please just bear with me. This is a kind of important to understand machine learning in the big picture. Supervised, I know the answer. Unsupervised, I'm looking for any answer. Reinforcement is about behaviors. So supervised machine learning is I give the machine lots and lots of data. I want it to recognize and be able to identify a picture. I want it to identify a cat in a picture. So I give the machine 100,000 pictures of cats labeled as cats, and then I show it a picture of a skunk. And it says, that doesn't look like a cat. Yay, I trained the machine. So I knew the answer, I gave it tons of answers, and it learned from me. Unsupervised is a different animal. Unsupervised looks at my data and finds correlations for me. This is the tell me something I didn't know approach. This is look at this data and cluster it together or find analogy or find anomalies. You know, what doesn't belong, what does belong. Find a correlation. And that correlation might be true, but not valuable. It might be correlation, but not causation. It might be something I've never considered before and really valuable. So the machine could say, online sales go up when the weather is bad. Okay, well, that's true. And the data proves it true, but I already knew that. And logically, I already knew that. So true, but not useful. The machine might say, when ice cream sales go up, drownings go up. So that's a correlation. Ice cream is not causing people to drown. The causative thing is something the machine was unaware of, which is the rise in temperature. It's summertime where more people eat ice cream and more people go swimming, so there's a correlation. But maybe the machine says, people who saw this ad and hit that landing page and chose this option are more likely to be persuaded by 10% off than they are by free shipping. That's useful. That I can make money on that. So unsupervised is find a correlation. Tell me something I didn't know. Reinforcement learning is, well, there's no actual perfect answer. It's, I want to put the right message in front of the right person at the right time. There's no absolute correct answer to that, but there is correct behavior. I'm looking for an outcome. I want more email opens. So I give the machine 1,000 subject lines to test. And it tests 100 of them and says, well, this half didn't work at all. This half was better. I'm going to go find another 50 in this 1,000 you gave me that look like those and test those. It's like multivariate testing, only really fast. And it gets reinforced for good behavior. So supervised, unsupervised reinforcement is what machine learning is all about. It's great at finding correlations. It's great at segmentation and clustering, finding the, hey, you've got 6 unique groups of people, you should message them differently. And here are a couple of people that don't belong in any category, what's that about? Or here are a couple of purchase behaviors that I've never seen before that are outliers, what is that about? And it could be bad data, it could be bad data processing, or it could be a business opportunity, or it could just be one of those weird things, but it's worth looking into. Your job is to figure out whether the results are interesting or useful and worth digging into further. Machine learning is incredibly valuable for rote work that humans, frankly, don't like to do anyway. So ranking, sorting, categorizing, clustering, finding those anomalies, that stuff the machine can crunch all day long and in fact can do it in a heartbeat instead of a human doing it all day long. So what do you use that for? Well, I just described email testing. So lead scoring, yeah, even meeting scheduling. I'll come back to that one. But personalization, social media monitoring, and of course, multivariate testing. All of that stuff is done by a person today, but doesn't have to be. And these are activities. They're not job descriptions. They're not roles. They are functions. And if you're responsible for one of these functions, the machine is not going to take your job, but it's going to automate a part of your job that had not been automated previously. So if you have programming and you have spreadsheets and you have predictive analytics, when do you use this machine learning stuff? The rules are pretty straightforward. First of all, you need a lot of data. We talked about big data before. In order for this stuff to work, you need humongous data. You need a lot of data. Give it 100,000 cats. Give it 1 million customers. Give it 1 billion transactions. Now, if you don't have that many, give it a try, and then definitely give it a try as a learning process. But number, let's see, 1, 2, 3, 4, simpler methods won't work, so you should use machine learning. Maybe you can do it in Excel. Maybe you can do it with a straight linear regression. Maybe the value of the results is so low and the risk is so low, you might as well flip a coin. That is a perfectly reasonable tool as well. But if you have a lot of data and too many variables for the human mind to gather, if your data is well labeled, if you really know your data and you've got a clear goal and you know, and if you get an answer that you can put to use, you will put it to use, then absolutely use machine learning. Well, if we're talking about tools, the classic question is, should it be R or Python? And the answer is yes. It should be one of those or both. And should you learn both? Not really. Basically, if it's written in R, it is probably statistical analysis. If it's written in Python, it's probably machine learning. But you know for sure that it is artificial intelligence if it's written in PowerPoint. So AI writ large, yeah, it's a buzzword. But Python and R, valuable tools for statistical analysis, for clustering, for finding that needle in a haystack. It's worth learning enough so you understand when to use one versus the other. But while you're thinking about how to use machine learning for solving particular problems, think what new problems the new tools can solve. And I'd love to give you a list, but I don't know. These are going to be industry specific, they're going to be company specific, they're going to be product specific, campaign specific. You're going to need to understand what these tools are capable of so that when you see a problem or somebody asks you a question, you can say, wait a minute, I'll bet we could answer that with machine learning because there's no other way to do it. And we've never asked it before because it's a ridiculously difficult problem to solve. But maybe, given that we have the data and a clear goal and good context, maybe this is the time to use machine learning. Now, I mentioned that machine learning is dependent upon an enormous amount of data, and it needs to be good. You've heard garbage in, garbage out. Well, it's even more critical now because machine learning is creating its own structure based on the data that it sees. It's creating its own model. It's not necessarily a logical model or a reasoned model. It's a statistical model. So it's hard to parse. It's hard to pull it apart and understand what's going on. So you need to be very confident that you have the data that's solid, clean, trustworthy, loyal, brave, reverent, all that good stuff, because you're going to depend on it. And there's a lot of ways that data can mess up. There are a lot of ways that you can get data that could be right, but isn't somehow. And when the machine kicks out an answer, you're going to be inclined to go, oh, that's the answer. But instead, you should be inclined to say, does it make sense? And are all of my data streams working properly? I want you to think about an analogy of a can of soup. I want you to think about 10,000 cans of soup being manufactured in a lot. And weeks after they're manufactured, reports come in that people are getting sick eating your soup. What do? Well, you go back to look at that particular lot. Where did the water come from? Where did the salt come from? Where did the chicken, the 7 different kinds of chicken come from? Who did we source the riboflavin from? What about the dehydrated onions? Now, chances are there is a supply chain steward for each one of those ingredients. You need to do the same with data. If you're looking at 7 different data streams coming in and you're building a machine learning model, somebody has to be responsible for the validity of each one of those data streams, because frankly, your job depends on it. You are going to look at the results and make a recommendation. The packaging should be blue instead of green. We should put these messages above the fold on the website. The email should include more information about this than that. And you're staking your reputation on the fact that you were able to read the tea leaves. You were able to look at the data and come to a conclusion. So you need to trust your data. Over and over, says Susan Ettlinger, the top 2 success criteria I hear for enterprise artificial intelligence are: 1, doing the work to build a data infrastructure. Now, that's not insignificant. That's a lot of work. We need to build a data pipeline, a data cleansing process, a data management system, a data lake for it all to go into. So number 1, do the work to build the infrastructure. Number 2, a willingness to learn from failure. The first is tactical, the second is cultural, neither is optional. A willingness to learn from failure, you think, oh yeah, we're agile, right? We do things in sprints. We're willing to give things a try and then fix it. Well, large corporations spending a lot of money, maybe a small software development team is agile and sprint-like and lean, but a large corporation says, no, we're going to be a little more careful than that. So if you implement a machine learning system and it does not produce results, the cost and the concern is going to be scrutinized really carefully. But here's the warning. Here's the big message behind what Susan is saying here. Learning from failure is literally how machine learning works. You give it a task and you give it some options to try out, and like a baby learning to walk, it falls over. It makes horrible mistakes. It makes decisions that make no sense. And it does it over and over and over really fast until it chances upon some lucky strikes. And then it learns and it gets better. It's like the baby taking a step and falling down, and then taking 2 steps and falling down, and taking 3 steps and going, wait, I think I've got this. And then it runs out the front door. Machine learning is like that. It learns by failure. So when you bring a machine learning tool online, it's going to be horrendous until suddenly it's not. So if the management team that's watching you looks at the initial failure and says, that's it, we're pulling the plug, they're missing out on the opportunity, and you might not be working for the best company. Okay, so choose your role, know your tools, know your data. Now I'm going to switch gears and talk about you individually. Be the augmented marketer. Use the tools not just to do analysis better, not just to do email better, but to do what you do better. You've probably heard about the T-shaped employee. This is somebody who knows something about everything and a great deal about one thing. So that's the shape of a T. Well, lately, no, really, we have to make it a pie shape, if you will, with 2 legs. Being a brilliant marketing person and having a lot of experience in marketing is great if you're in pharma, but if you take that pharma and apply it to finance or packaged goods or manufacturing, you're a fish out of water. So you need to go deep on your industry and deep on marketing. And oh, guess what? Nope, we got a 3rd leg here. You also have to understand the analytics. So augment your knowledge. Spend the time to learn what you can. Read the books, read the blogs, get involved in the online discussion groups about your industry, about marketing in general, and yeah, about analytics. But then train your bot. bots. Use artificial intelligence to do your thing, whatever your thing is on a daily basis. That's not the company thing, it's your thing. My thing is writing, and I occasionally will make up a word, and Microsoft Word says that's not a word, and I say, but I want it to be. So I add it to the dictionary. I have just trained Microsoft Word into how I do words. Now I can use an Excel spreadsheet to count the cells between dates or produce rank functions, for example, or I can write whole-on macros, and I can teach Excel how I think about numbers. Now those macros, that's like teaching Word about my vocabulary. I've trained it. I mentioned before using artificial intelligence, machine learning, to schedule meetings. Here's a tool, fabulous. It's called X.AI, and it looks at, you give it access to your calendar, and it looks at what your responsibilities and your availability are, and you send an email to somebody and say, hey, let's get together for lunch sometime next week. This system looks at your calendar and says, oh, well, here are the days that you are available, except for that one. You're available from 12 to 1, but the person you want to have lunch with is half an hour away. So you actually need 2 hours, a half an hour to get there, an hour for lunch, half an hour to get back. It's smart enough to do that. And then it engages with that person over email to negotiate a time for the meeting. And the next thing you know, it's sending you a message back saying, okay, your meeting with Susan is going to be at such and such a time on this date. Now, here's the fun part. If multiple people are all using this same X.AI system, and you say, I want the 10 of us to get together for a meeting, it will schedule that meeting in nanoseconds because it is looking at everybody's calendar already, and it will find an appropriate conference room and book the conference room. It learns about your preferences. It's not just looking at your calendar. It knows you don't like to do meetings on Friday afternoon. It knows that you have not necessarily a set meeting every week, but you always say no to 2 o'clock on Thursday. So it takes that on board and it learns about you and how you schedule meetings. I've been using this thing called Auto Hotkey for about 10 years, and I use it in the simplest way possible, just for keyboard shortcuts. I got so tired of typing my email address and copy and pasting my company's postal address. And now it's just, I hit keyboard shortcut, boom, it does it. But you can use Auto Hotkey for scripting all of Windows if you want to. And then let's full circle going back to writing. This is Google filling in not guessing the next word, but guessing the rest of the sentence. If I'm inviting you for chips and salsa and I'm going to make guacamole, and I type in my space A, it's going to guess that I'm talking about my address. It's going to suggest that and just, oh, hit return and boom, I've done that already. Now, I've talked to people who've used this and they say it's pretty lame at first, but then it learns about your phrasing. It learns about what you are likely to say next, and it gets pretty good. So your job is to train all of these bots to work with you. This is not company intellectual property. This is your valuable asset. This is your bot. These are your superpowers, and you're going to put them into your LinkedIn profile. You're going to put them on your CV. And when you walk into a job interview, yeah, I know Word and I know Tableau and I know Google Analytics. And oh, by the way, I also have a half a dozen bots that automate a bunch of stuff for me. That's what being an augmented marketer means. Number 5 is going back to this whole world of marketing. So we're going to leave you behind for a minute and tell you about something you need to prepare for, because branding has become important again. I'm guessing that because of this audience, you're the kind of people who definitely has one of these devices in their home. So when they do an analysis and they say 30% of homes in the USA have a device you can talk to, I'm guessing actually it's probably only 25%, because I don't know about you, but I have several. These are becoming shopping conduits. I can buy things, I can ask Alexa to send me a dozen AAA batteries. And if I don't specify, guess what I'm going to get? Amazon branded batteries. But maybe if I asked my Samsung Galaxy, I would get Samsung branded batteries, which means that as a marketer, your job is to make sure that your product is top of mind so that, yes, they ask for it by name. I need to ask Alexa, send me Duracell AA batteries. So you have a responsibility to spend the money and do the metrics and make sure that it's working so that people are ordering your product verbally. First, if it's good, it'll ask you. It's like, which kind of batteries would you want? Then it would learn and say, do you want the same as before? And maybe it's paying attention and says, hey, you know what? All of your friends are ordering this kind. Do you want to order this kind instead? And then finally it says, yeah, I got this. I know what you need. I can take care of it. Well, now we get down to machine marketing. And here's where I believe that marketing is about to get really weird. You know what business to consumer is, you know what business to business is, but I think we're going to look at a sea change coming up here pretty soon. And there are some premises. Premise number one, customers will own their own data. We're pretty freaked out by how our data is being used by Facebook. We're pretty freaked out by our data being stolen from the companies that are keeping track of us on a daily basis. What if customers store their own data? Now, here's how this would work. Today, my data is spread all over all of these apps. I've got it. Each one of them has my email address. Each one of them has my preferences. Each one of them has my phone number for two-step verification, all of that stuff. And if, heaven forfend, I change one of these things, I have to go tell all of these apps and websites and vendors that something has changed. It's a pain. Also, I don't trust them. What if we flip the script and say, the customer owns and stores their own data? So the customer finds a place where they keep their data and they keep it secure and they give access to all of those apps and all of those websites. So that if I change my phone number, heaven forfend, everybody, well, they don't find out, but the next time they access, they see what the current thing is. Now, how do I keep my data secure and I'm confident in it? Okay, well, you knew we were going to get through this without saying blockchain, right? Those of you who are playing buzzword bingo at home, yes, you can check off blockchain. Okay, so the goal is that I'm confident in my own data, that I control my own data, and I run my own agent on top of it. So my personal agent is in it for me. It is my agent. It is not Google, Apple, Facebook, Twitter, Amazon, Microsoft, IBM, the government. It is mine, and I own it, and I store it, and I have control over it. It knows everything about me, and it's well protected. And I give access to those that I wish. So if I want to buy something from you, I will give you access to my credit card information and my postal address for shipping. And I will, if it's something big, I will grant you access to my credit score. I will grant access to my doctor for all of my medical information. And I will give access to my CPA to all of my financial information, but not vice versa. My doctor has no reason for knowing all about my finances, period. And kicker, it's going to be proactive. It's going to work on my behalf. It's going to say, hey, Jim, I've detected and predicted that your dishwasher is going to fall apart next month. And I found a bunch of them that will fit in your kitchen. And I found a few that will fit your kitchen style. I found 2 that you can afford. One of them can be delivered on Thursday when you're already going to be home waiting for the garage door repairman to show up. And I've negotiated the best price. Do you want it installed, yes or no? it will do that on my behalf. It will detect a problem. It will identify the best possible solution for me. It will negotiate on my behalf. And my interaction is say, yes or no. Yeah, I'm ready, or no, I'm not. Or it'll recommend that I put it on layaway because it's also watching my finances. I am ready for the Jarvis or the Jeeves or the machine that knows enough about me that it can do this work. Because the ultimate convenience is having to do nothing. I subscribe to furnace filters, to printer ink, and to a special kind of face soap that my wife likes that I can't buy in my local town anymore. And they just show up. And I can adjust when they show up very carefully so that they show up exactly when they're needed. That means we're moving from shopping and shipping to shipping and shopping, which is what Stitch Fix is all about. They send you a box of clothes. You say, oh, yeah, I need that. I need that. Oh, yeah, no, that's not really my taste. Send it back. And their algorithm goes, okay, now we know for next time. The ultimate convenience is having to do nothing. So this myth of the AI apocalypse, don't worry about it. It's not going to take your job. It's just going to automate some very specific functions. And you will always be needed because your job, you will have three main jobs forever and ever. One, what problem would you like to solve today? Because the computer can't just suddenly decide to fix your email or solve for search. That's you have to prioritize that. Then, what data do you want the machine to consider? It can't just randomly find other data, or suddenly it occurs to the machine, maybe it should look at this other thing. That's what humans do. But the biggie is evaluating the output. If the machine says, oh, I can solve this problem with this data, and all you have to do is send 10,000 emails to everybody in your list, well, statistically, that might be true. But practically, tactically, reasonably, logically, no, that does not fly. So what problem do you want to solve? What data should the machine look at? And does the answer make sense? And if it doesn't, change the model, or maybe there's something wrong with the data. In any case, if you are this between the business stakeholder and the data, if you're the analyst, I think that's the most interesting place to be, because you're taking business problems and translating them into data problems. I don't think the best technology is the solution. I don't think the best algorithm is going to give you the leg up. I don't think the best data is going to give you, in fact, I don't even think the best vision is going to give you the competitive advantage. I think the person who asks the best questions is going to be the winner. We have tools now that let us ask questions we could not ask before. If you know your customers well enough and you ask really good questions about their behavior and their attitude and make good predictions, if you ask the best questions, you're going to be the one who wins. And if you do those 6 things, you'll still have a job when artificial intelligence comes around. And I want to thank you all very much for paying attention and sticking with me on this. I'll be on the Slack channel to answer questions. I look forward to them.
Thanks so much for watching this presentation. Join us on the Analytics Nexus Slack to talk with our presenters about this topic and more.